Hi students, we've learned so much in this entire, series of chapters relating to metals and non-metals. We've learned about the physical properties of metals, we've learned about the chemical properties of metals, we've learned why metals combine and why non-metals combine. We've even learned about the extraction of metals from their ores, the corrosion of metals and the alloys of metals. We've learned so much. Let's now summarize everything, so that the important concepts stick in your mind. Let's do that. Well, the first thing that we learnt in this section was that elements can be divided into two categories, metals and non-metals. Remember, we had learned that. The second thing we had learnt that metals are those elements which are lustrous, malleable, ductile, and even good conductors of heat and electricity. We had learnt that almost all metals are solid except mercury. So we had learnt all this when we had studied about the physical properties of metals. We had even learnt, that non-metals on the other hand are not lustrous, of course, apart from iodine, which is an exception. They're not malleable, they're not ductile, and we had learned that they are not good conductors of heat and electricity. We had also learned that diamond and graphite were exceptions. Diamond is a good conductor of heat and graphite is a good conductor of electricity, and both are forms of carbon. We had learned all this in the previous chapters. Of course, if you've forgotten, malleability means the ability to be drawn into sheets, while ductility is the ability of a substance to be drawn into wires. We'd even learned that metals, form positive ions. They give off electrons. And when they give off electrons, positive ions are formed. Non-metals similarly accept electrons. And when they accept electrons, they form negative ions. After studying about all these properties, we had moved on to the chemical properties of metals. We had learnt that when a metal reacts with oxygen, it forms the metal oxide. Of course, metal oxides in general are basic in nature. We had learned that too. So they turn, red litmus blue. We had learned that zinc and aluminium were exceptions and they form amphoteric oxides. We had similarly learned that different metals react with water at different rates. For example, potassium, sodium, calcium and magnesium, they react with water. Magnesium reacts with hot water, though it does not react with cold water. Aluminium, zinc and iron, they do not react with water, but they react with steam. We had learned that copper, silver and gold on the other hand don't react with even steam. So basically different metals have different reactivities with water. We had learned that sodium, potassium, calcium, magnesium, aluminium, zinc, iron, all of them produce hydrogen gas with acids. However, copper, silver and gold do not produce hydrogen gas with acids. They don't react at all. However, we had also learned that gold reacts only with a certain acid called aqua regia, which contains nitric acid and hydrochloric acid. We had even learnt about the activity series, remember, which arranges metals in their order of reactivity. We had learned that gold is the last in the activity series, while potassium is the first. Then comes sodium, calcium, magnesium, aluminium, zinc, iron, and so many other metals. We had learned that metals above hydrogen displace it from water and acids. Metals below hydrogen don't displace it. That's why iron, zinc, aluminium, all of them displace hydrogen from water and acids to evolve hydrogen gas, while copper, mercury and silver don't. Then we had come to the extraction of metals from their ores. We had learned that, ores are first concentrated or purified. We had learned that very reactive metals are extracted by electrolysis. Moderately reactive metals are extracted by first heating them, and then reducing them with carbon or aluminium. When we heat carbonate ores, we heat them without oxygen. When we heat sulfide ores, we heat them with oxygen. We had also learned that less reactive metals like copper, mercury, they are extracted from their sulfide ores simply by heating. We had seen how different categories of metals in the reactivity series are extracted by different means. Of course, metals that are extracted by heating or by reduction with carbon, they are generally impure and they are purified by electrolytic refining. We had then learnt about the rusting and corrosion of metals. We had learned that iron combines with oxygen and water from the atmosphere to form rust. We had learned that both air and water are required for rusting. We had learned that aluminium does not really rust or get corroded because of a protective layer of aluminium oxide that forms on it, isn't it? So we had learnt about all these things in this chapter. We had even learnt that rusting of iron can be prevented by painting, oiling, or even galvanization, tin and chromium plating. We had learnt these methods to prevent the rusting of iron. All these methods, prevent the rusting of iron by cutting off the contact of iron with the atmosphere. When iron does not come in contact with the atmosphere, it does not rust. There you go. We had even learned the uses of different kinds of protection. For example, painted iron is used in iron pipes, oiling in machine parts and gears, while tin and chromium plating is used in bicycle bells and drums. We'd even learnt about alloys. We had learnt when two molten metals combine and when they are solidified, they form an alloy. Alloys have different properties from metals. They are stronger, they are harder, they conduct electricity less, their melting point is lesser than that of constituent metals, and of course, they also corrode lesser. So there, I have summarized this entire section for you. Hope you enjoyed this entire section and also understood it. Let's now move on to the next section.